Welcome. In this video, we'll be taking a look at section 2.4 with some right triangle applications. Let's jump into our first example. So we have a man is walking away from a 20-foot flagpole. When he reaches point B, the angle to the top of the pole is 60 degrees. That's shown in our picture here. And when he reaches point C, as he's walking away from this flagpole, the angle to the top of the flagpole is 50 degrees. And so we see that in that second image there. So we want to find the distance from the flagpole at point B and at point C. So we want to find those distances. So we're really looking for this x value here between A and B, or B and D, excuse me. And we want to find the distance from point D to C. So one thing we could do here is just highlight maybe a second value. We'll call this y that spans from point C all the way to the flagpole. So this would be the full distance there. So let's consider first how we would calculate the value for y, that full distance from point C to the flagpole. And we'll just call this variable y, that whole distance. So if I want to consider that distance here, notice that we have a right triangle on this outer edge formed with our flagpole and the ground. I'll highlight that in blue. That big right triangle over here, and we have an angle here of 50 degrees. So I can consider the relationship between the sides of my triangle that I want to relate. I know the flagpole is 20 feet, and I want to find that base side of y. So I can say that the tangent of my 50-degree angle, that would be equal to the opposite, and to the opposite would be the 20 feet of the flagpole, divided by the adjacent side, which is the y. So the opposite over adjacent is always our tangent. So just to recall, tangent of theta equals my opposite over my adjacent. And so for this, that would be 20 feet over y. Okay, this is a good opportunity to try to rearrange this equation because we have a variable that's in the denominator of that fraction. So let's rearrange this. We'll multiply y on both sides to start. That will be y tangent of 50 equal to 20. And then we can divide both sides by the tangent of 50. Remember that the tangent of an angle is a constant number. So we can move it around like a constant. This is y is equal to 20 divided by tangent of 50 degrees. Now, if we put this in our calculator, 20 divided by tangent of 50, we'll find this to be 16.8 feet. 16.8 feet. And here we just want to round again to the nearest tenth, so we'll do that as the directions have displayed. So 16.8 feet for my full length of y. That's the distance from C to the flagpole. Now let's take a look at the smaller length, and we'll highlight this one in a new color. This x length going from B to D. We'll notice that this also has a right triangle involved. We have the hypotenuse, the opposite side, and the adjacent side. In this case, we're using the angle of 60 degrees. And again, we can use a tangent function. So we can say that the tangent of 60 degrees this time is again the same ratio. The opposite is 20 and the adjacent this time is the value x. Again, we can rearrange this equation to solve for x. Multiply by x on both sides. And then divide by my tangent. And again, we'll go to evaluate this in our calculator in terms of degrees. If we go to find this, we'll find that this is going to be 11.5 feet if we round to the 10th place. So we have our distance from B to the flagpole and our distance from C to the flagpole. So this is our, in blue, we go back to that. This answer is from C to the flagpole. And this is our distance in red. That is our shorter distance here from B to D, or B to the flagpole. All right. So now that that's complete, we'll take a look at a second example. This one is looking at an isosceles triangle. So the two equal sides of an isosceles triangle are 24 centimeters. That's shown in our picture. If each of the two equal angle measures are 52 degrees, we want to find the length of the base and the length of the altitude. Okay, so we have an isosceles triangle, meaning we have two equal angles, two equal sides. And we'd like to go out and solve for two things, the base and the altitude. All right, so let's begin by maybe working on the altitude. We'll start with that. If I consider that altitude, right now it's labeled as the value of x. And we also know if we highlight kind of half of this triangle, we really have a right triangle going on here. We'll just highlight the left side. And so here, if we wanted to solve for side x in relation to the angle that we know, that's 52 degrees. If I'm sitting right here, I want to go out and find my opposite side. That would be opposite. And I know my hypotenuse. So when I consider what function I need the trig function that relates the opposite side and the hypotenuse. And that would happen to be the sine function. So let's take a look at the sine of 52 to start. So we're going to do the sine of 52 degrees. That would be the opposite divided by the hypotenuse, which happens to be 24. So to solve for that altitude, x, I just need to multiply both sides of this equation by 24. And so when I look at that, I have the x is going to be equal to 24 times the sine of 52. And so if I go for x here, in this case, we'll maybe round to a couple decimals, just so we're thorough here. We'll find that this is going to be 18.91 centimeters. So we have our altitude. The next item that we were wanting to find here is the base of this triangle. So let's see if we can use that same angle to go out and find the base. So again, the base of this triangle is from A to B. That's the whole base length here. So one way I can think about doing this is to find this y length on the base of this right triangle and then multiply that by 2. because we know that these two have equal length here. So let's go out and solve for y, and then we'll multiply by 2 to find the base of this triangle. So again, if I wanted to solve for y, I know the angle of 52. Y side would be my adjacent side, and I already know my hypotenuse still. So that would lead me to choosing the cosine function. So I'd want the cosine of 52 degrees. That would be my adjacent y divided by my 24 again. So when I consider solving for y here, I can multiply by 24 on both sides. And so my y value, or half of my base, is going to be 24 times cosine of 52. So if y, we'll write this down one more time, is equal to 24 times the cosine of 52, this we'll find is going to be approximately 14.77. And that's in centimeters again. And if we wanted to find the full base, the base is just going to be equal to 2 times the length of y. So if I do 2 times the length of y here, we'll get approximately 29.55 for that result. You put that into our calculator. And that's in centimeters as well. All right. In our next video, we'll be taking a look at a few more examples with some applications and some directional triangles. So I hope to see you in the next video.